Hello, greeting everyone. In this video, we will discuss the super hexagon for trigonometric identities like quotient identities, reciprocal identities, Pythagorean identities, and the product identities. So super hexagon, kailangan lang nating alamin kung paano gamitin ang super hexagon or magic hexagon para hindi na natin kailangang mag-memorize. Alamin lang natin kung saan nakalagay si sine, cosine, tangent, cosecant, secant, at cotangent. But first, let's identify the definition of superhexagon. So the superhexagon is a special diagram that helps you to quickly memorize different trigonometric identities, such as Pythagorean, reciprocal product or function, and cofunction identities. Also, you will learn how trigonometric identities are useful to evaluate trigonometric functions. So sa madaling salita, we use superhexagon para mas mapadali ang pag-iintindi sa mga formula ng trigonometric identities. We now have the superhexagon, and we start writing from this vertex, go around the hexagon, and end at this one. It's simple, we just draw a hexagon, join its opposite vertices, and write one in the center. Now, let's see how we write the sixth function at the six vertices. We just need to remember one formula, which is the tan is equals to sine by cos. So, how tan is equals sine by cos? So, we start at this vertex and write tan. So, since tan is equals to sine, we will write sine here in a clockwise direction. So, tan is equals to sine by cos. So we have now tan, sine, and cos. Now, three functions and three vertices remain. So we write cot here since cot is opposite to tan. And we need to remember that cotangent is opposite to tangent. So what remains is cosec and sec. So if we draw a vertical line in the center of our hexagon, we will have the three vertices on the left and three on the right. So to remember what's written on this vertex, just remember that we have all functions starting C on the right side. So we write cosec here and sec here. So we have now tan, sine, cos, cot, cosec, and sec. That's all you need to remember about how the super hexagon has to be drawn. So next, a hexagon with three diagonals. We have 1, 2, and 3. So we have three diagonals and the vertices. We have 6 vertices here. And the number 1 at the center. So let's write tan, because tan is equals to sine by cos, and cot opposite to tan, and cosec here since all c's are on the side, and what remain is sec. So again, para makagawa ng isang super hexagon, we need to write three diagonals. We have 1, 2, 3, and the 6 vertices we have 1, 2, 3, 4, 5, and 6. And write 1 in the center. So after that, we will write now the tan is equals to sine by cos, and cot opposite to tan, and cosec since all c's are on the right side of the super hexagon, and what remains is the sec. Let's try going around the hexagon in the clockwise direction. So we go like this. from tan, sine, cos, cot, and cosec, and sec. So it is in the clockwise direction. And this tells us that tan, sine, and cos are equals. So we have tan theta is equals to sine theta by cos theta. And that's how we started making our hexagon. Now let's see the next three functions in clockwise direction. So next, we have here now the sine, cos, and cot. So we have sine theta is equals to cos theta by cot theta. We have here the first, second, and third. First, we have second and third. So next, we have now the cos theta and cot theta and the cosec theta. So we have 1 and 2 and 3, and now we have cos theta is equals to cot theta by cosec theta. Now we have cot. So from cot, cosec, and sec. So we have cot theta is equals to cosec theta by sec theta. So again, we have cot theta is equals to cosec theta by sec theta. Next, we have now the cosec theta. From cosec theta to sec theta and tan theta. So you have now the formula of cosec theta is equals to sec theta by tan theta. So we have first, second, and third. And the last one is the sec theta, tan theta, and sin is sine theta. So we have first, second, and third. So our formula now is sec theta is equals to tan theta by sine theta. So now we have our one hexagon with 6 formulas. Next, we draw the super hexagon and write 1 in the center. And write tan is equals to sine by cos, and since cot is opposite to tan, and since all this is on the right side of the hexagon, we write cosec here, and what remains is the sec. In the previous set of formulas, hindi natin ginamit si 1 na nakasulat here in the center. So, let's see kung bakit nakasulat dito sa gitna si 1. So, we have here the mas maayos na figure of if we multiply the functions at the opposite vertices, we get 1. So, again, if we multiply a functions at the opposite vertices, we will get a 1. So let's start with sine theta and cosec theta. So if we multiply sine theta to cosec theta, we will get a 1. So we have here, first formula, we have sine theta multiplied by cosec theta is equals to 1. So next we have cos theta and the sec theta. So if we multiplied cos theta to sec theta, we will get this second formula, which is the cos theta multiplied by sec theta is equals to 1. So let's move on with the third one. We have now the cot theta and tan theta. So if we multiply tan theta to cot theta, we will get this third formula, which is tan theta multiplied by cot theta is equals to 1. So when functions are diagonally opposite vertices, So, when functions are diagonally opposite vertices are multiplied, we get a 1. So next, if we take any three continuous functions in the hexagon, like tan, sine, and cos, and tan multiplied by cos will give us sine. So, if three continuous functions are taken the product of the first and third functions, the result of the function is in between them, which is the sine. So we can say that tan multiplied by cos will get us sine. Will give us a sine answer. So again, if tan multiplied by cos will give us sine answer. So we have here this one. So if tan multiplied by cos will give us sine. So tan theta is tan theta multiplied by cos theta is equals to sine theta. And if cot theta and sec, if cot theta multiplied by sec theta will give us cosec theta. So we have here sec theta multiplied by cot theta is equals to cosec theta. So again, if tan theta multiplied by cos theta will give us sine theta. And if sec theta multiplied by cot theta will give us cosec theta. Even cosec theta multiplied by tan theta will give us sec theta. And if cos theta multiplied by this cosec theta will give us cot theta. And we have a lot of. So in short, the first term multiplied by the third term will give us the term in between them.